I'm Lori McVitie. I am the Principal Technical Evangelist with F5 Networks. I work in the office of the CTO. I mostly know things and I write. So I don't actually do anything. That's these guys over here who are going to be talking in about 10 minutes. Okay? I'm going to take up about 10 minutes. I'm going to talk a little bit about F5 and about digital transformation. And then I'm going to hand it over to Colby and Brian from Zipwhip. And they're going to talk to you about actually how they did their migration to AWS and how they accelerated that and some of the challenges that they experienced and how they overcame them, obviously, because they're running there now. And then we'll have some time for questions and answers. Maybe more questions than answers. Maybe more answers than questions. I'm from Wisconsin, so you don't have to ask that one if you hear the accent. So we got that one out of the way. So I have 4 children. The youngest is 11. Okay, sorry, is 12. And he has not known a time in his life when the cloud, when AWS did not exist. It's always been there for him. Screens are all touch screens, and Wi-Fi is available at home, at school, at church, at Walmart, in the car. It doesn't matter, right? The internet is ubiquitous to him. He is the very definition of digital native, okay? My other 3 children are 26, 30, and 32. They are not digital natives, although they like gadgets. But they have experienced the painful, sometimes, transition of moving from VHS to DVD to streaming to the internet actually being available everywhere other than through a dial-up modem. Most organizations that we see, including our customers, are more on that second side. They have mixes of different applications. They've been around for a while. They have existing architectures, existing networks, and they want to migrate to the cloud because there are advantages to it. We call that digital transformation, moving from mostly human-driven manual processes, right, to data-driven and automated processes. And the cloud really helps with that and accelerates that process because it's built with that in mind. And what most organizations want from digital transformation is things like a better customer experience, right? They want to be able to change business things really fast, right? Processes, their entire business perhaps. And of course, they want to get a return on their investment, right? They're not after the latest gadgets like the kids, but for the enterprise, that can be the new gadget. What is the new service? What is the new way of doing something? What new data can I get? Along the way, because digital transformation is a journey, you're going from a beginning state to an end state. You are somewhere in between. And you're going to encounter challenges. Everyone does, especially if you have something existing that you're trying to migrate or move, or even refactor or rewrite to run in the cloud. And what we see is that people have problems with infrastructure lock-in. You have existing things in the data center that don't necessarily run well in the cloud or run at all. You have problems with security. This is always our #1 cited challenge with doing things in multiple clouds or in the data center in the cloud, doing a hybrid cloud, is security. We can't deploy the same security policies. We don't have any consistency with our security. We don't know what to do. And then tool sprawl. Because in case you've noticed, if you've got existing equipment, infrastructure, on premises, you have existing tools that help manage them and operate them, and you use them to deploy them. Those don't always translate to the cloud either. So migrating can be a challenge for most organizations. And that's because in between the code that your developers write and your actual customer are a bunch of different services. Highly simplified. I don't claim this is an actual network diagram. Okay, because it's just obviously it's a depiction, right? There's services in between, though. Code's deployed on your app server, your web server. It's going to maybe have an ingress controller if you're doing cloud native. You're going to have an API gateway, load balancing, all of these security services, and then finally to your customer. Okay, we call that the data path. And it's full of different kinds of services. We know from surveys on average that there are anywhere from 8 to 15 different services for an application that provide scale or security or acceleration. Now, each of those services is probably provided by a completely different vendor, right? Because nobody has all of these tools in that path. No one, right? Just doesn't happen out there. And complicating things is that sometimes different application architectures have different tools. If you've got a monolith or a 3-tier web app that was written in, I don't know, the last time I touched code, 1999, right? It was probably deployed on something like, I don't know, WebSphere, right? Or maybe Apache, maybe Tomcat. Modern apps, the cloud native services, right, are usually deployed on things like Nginx, maybe something a little more modern, right? Containers, different architectures, different tools to deploy and operate and manage them, different services to secure them and scale them and deploy them. So that's going to complicate things. Because what it does is, unfortunately, it creates operational silos, okay? Right, inside the organization. Enterprises aren't greenfields. They didn't start out with a DevOps mindset and everybody's collaborative. They have silos and they have different organizations that deal with networking or security or storage or their apps. And then you add in different kinds of applications and you add in another layer of complexity. Now you have people that are specialized in microservices and Kubernetes, and then there's other ones that are specialized in that mainframe app that's still running, which 11% of organizations that they still have mainframe apps running daily, their business. So they've got to manage all of that complexity, right? And that adds up into cost because it's human intensive to be able to manage all of these different things. You want to use automation and orchestration in order to improve that. But we don't all play well together, right? There's no one tool to rule them all. There has not been in the past. There still is not a single tool that you can go to and just say, hey, just make this deployment thing work automatically. I want it to work. Doesn't happen because there are different vendors and different models and different APIs and different UIs and different CLIs and different environments. So that means that you have to do that yourself. So you have to build the integrations in between there to make that work, to stitch together a pipeline so that you can actually deploy apps faster. When you add in the cloud, you have other tools that you have to bring in, and you have to stitch those together with things you may have on premise, and you have to try and figure out how to make all these things work. And then once you do, you still have the problem of, oh, wow, something isn't running fast enough. Something has failed. Where is it? What's the cause? Now, generally, being F5, we get blamed a lot for that because we're in the data path, and if you're in the data path, you're going to get blamed for it. So you can spend weeks, right, just sifting through logs and different systems that have collected this error information, trying to figure out who's at fault, right? It's time-consuming, and it's frustrating because by the time you figure it out, the customer's already left, or is angry, or has tweeted something really mean in their stream, and it's got retweeted, and it's just a big mess. So we understand that. So why is F5 talking at a cloud conference? Does this make sense, right? We're the hardware load balancers, right? Everybody knows that, right? Big IP, it's hardware. Well, that's where we started, right? We started as actually a software proxy that needed hardware in the 2000s to scale along with the internet. Because the hardware back then was a bunch of 386s that couldn't do anything. So we had to go to specialized hardware in order to scale the internet early on. And it was just a load balancing proxy. And then we went through a little digital transformation. We went, wow, okay, we've got this proxy, and people need other things like, I don't know, security. Right? So we built all of these plugins, these modules that could sit on top of this and created what's called an application delivery controller, an ADC. Just a market name for a proxy with plugins to do different things. And it sits on hardware. And all was good with the world. And then came the cloud. Actually, the cloud showed up about 2007, 2008, right? But until it started getting big enough, it didn't have the impact that it has had since then. And it changed everything. Because now people wanted to be able to run in both environments. They want to be able to just pick up an app and move it there, but they have all of this existing infrastructure. They have services that they depend on. So how are they going to do that? We said, well, we'll just take the software apart from the hardware, right? That's where we started, and we'll put it in a VM, and we'll make it run in the cloud. And we will get this all over the place. So now we support all these environments. Isn't that great? But you see we're missing some services here. We only have a few here. We don't have that whole data path. So earlier this year, you may have heard, we acquired a little company called NGINX. Just a little big, right? All right, so they have a lot of the other services that we didn't necessarily have. So app servers, web servers, right? NGINX is one of the biggest drivers of websites and web apps today. We got ingress control, we got containerized solutions, we've got a lot of different solutions. So we have been focused on integrating this. Now, it's not just enough that we acquired them. Now we have all these different services, right? Our focus right now is not only being able to run in AWS or being able to run in the data center or a VM or in a container, but also unifying that, because tool sprawl and consistency are the biggest challenges that we see our customers having when they try to migrate to the cloud, because they still have apps in the data center. So we're trying to unify that to provide a better operational experience, so you can consistently deploy security in multiple places. So it's the same, so it complies with policy. But that's not enough either, right? Because it's not just about being able to do all those things. It's also being able to operate and manage them. Because after day one, people have to actually maintain that application and all of the services in between. So we are focused as well on integrating with ecosystems like AWS, where our customers want to be, with Kubernetes, with Terraform, with all of the different systems that are out there that people are using to orchestrate and automate all of the deployment pipeline and manage that operation. And that was very important when Zipwhip went to migrate to AWS. They wanted networking that worked consistently on premises and in the cloud. And they also demanded automate all the things. Must be automated. So our ability to do that, to provide across the data path consistency in the networking, and then also provide, right, the automation and the integration with the right ecosystems, was in part, helpful to them as they migrated to AWS. And so now my 10 minutes are up, and I'm going to turn the stage over to Colby Allen and Brian Yamanaka from Zipwhip, who are going to tell you more about this journey themselves.
Thank you, Lori, and thank you to the folks at F5 for allowing us to take this opportunity today to share with you our migration story to AWS. I'm Brian Yamanaka. I'm the Director of Technical Operations at Zipwhip, and this is Colby Allen.
So I'm the Platform Operations Architect. I help design all of Zipwhip's cloud infrastructure.
So before we get into some of the technical details of our migration, I wanted to give some context about what we do at Zipwhip and why migrating to AWS was so important to us as a company. So Zipwhip, we operate a SaaS platform as well as an API that allows our customers to send and receive text messages using their existing landline or toll-free phone number. And this software provides sort of an iMessage-like an interface for you to send and receive those messages to your customers' handsets within their native messaging application across all the United States carriers. So you might be wondering, why text messaging? Why is this important? Why are people texting versus calling their customers? And so in our 2019 State of Texting report, we found some of these trends among consumers and businesses that send text messages to them. So it's fast, it's easy, it's convenient. Today when I get a phone call from a number that I don't recognize, I get this little bit of anxiety. I'm like, should I pick this up? Do I have to talk to someone on the phone? But with text messaging, it's fast, it's sort of asynchronous. You don't feel like you've got to change context and have this conversation with someone on the other end. You can reply back whenever you want. And as I said before, our platform is able to send messages directly to your native messaging application, so your customers don't have to download a separate app. They just open their messaging application and they can start sending and receiving messages with you. And text messaging is also very effective. We've seen that about 74% of consumers on their mobile handsets, if you look at your phone right now, typically have 0 unread messages. Now that's different. If I look at my email inbox, I think there's a comma and a lot of zeros next to how many unread messages that I have. And also about 74% of our consumers end up texting back and replying in less than an hour. It's a preferred mode of communication. 75% of consumers had told us that they're frustrated that most times they can't reply back to a text or call. Short code messages, not many are two-way. So a lot of times those are used to send you appointment reminders and notifications. Most of the time you can't respond back to those. I think about the times when I get text messages for appointment reminders with my dentist. So who likes going to the dentist here? Yeah, I find every excuse to reschedule. So what's nice is when I get that text message reminder, it allows me to respond back and make up some fake excuse that I can't make it today and that I can reschedule. So that's why it is a preferred means of communication, and a lot of times people find it far more convenient than a telephone call. So now let's get into our migration. We broke our migration up into 4 main phases. And you can see here on this chart that goes back to really when we started in the text messaging business back in 2014, that we experienced some tremendous growth starting in 2018 there, as denoted by the yellow vertical line. This phase, we spent a lot of time planning and trying to understand why we were seeing so much growth across our platform. I mean, you can see, I think it's important to note here that we were already experiencing the growth as we were trying to go through this planning phase. So Colby and his team are trying to pull these levers to make sure our platform stays online, all the while we're trying to move to AWS. And so from planning, we decided to start with our SaaS app, which is our web interface that allows our messages to send and receive text messages. And to do that quickly as we were starting to build out in AWS. About the second half of 2018, as we really started to see a growth in traffic across our platform, we decided to move our core carrier-grade network. So this is the network that transacts the actual message into the mobile operators and to the consumer's handset. So this is important for us because, again, we have been growing at about 200 to 300% month over month. That's tremendous growth. And I don't have to tell you how difficult that is to try and keep the network online while you're growing so quickly. We ended up rounding out our migration to AWS in the fourth quarter of 2018 when we moved our integrations platform. So this is the platform that allows our customers to sync their messages into CRM systems like Dynamics and Salesforce and more industry-specific verticals. But I think the main theme here is we did this in under a year. This is a tremendous undertaking. We pulled things out of data centers, and gigantic platforms, monolithic platforms, and moved them into AWS very quickly. So all this translated into about 280% growth across our messaging platform as we're trying to move to AWS. And it's important to note the factors that contributed to this growth to, again, give you more context into why we made this transition. So we had started seeing more extreme growth in application to peer texting, which is different than peer-to-peer texting. Peer-to-peer is where you would send a message to your spouse or family member through an iMessage-like app. But application to peer texting was really starting to take off with businesses and some of our large resellers as they wanted to send bulk messaging to multiple handsets at one time. This translated into that about 280 to 300% growth in 3 months in early 2018. And we were also having significant capacity challenges in our Midwest data center. So yes, at the time we were still running in a data center, and a lot of that hardware had started running out of space. We were running out of compute. I mean, it was a tough time for us, and so that really helped accelerate sort of that drive to get to AWS quickly. And then all this capacity challenges really translated into some uptime issues that we had in the second quarter of 2018. I'm not going to give you specific numbers because they may be too gory, but we had a hard time staying online. And that was another reason why we decided to move to AWS to increase our reliability, stability, and uptime across the platform. So I'm going to hand it off to Colby now. He's going to talk through more of the technical details around our migration.
Awesome. So our migration, we had a very interesting starting point. So we ran 3 data centers. We had 2 edge data centers and 1 core central data center that ran everything. We had a partially built 4th data center, and it was very partially built. Our legacy data center had actually suffered a lightning strike 3 months before we both started at Zipwhip. And so we had a data center that got fully taken offline, rebuilt by hand as quickly as possible to get the application back online. So we were dealing with stuff with that. We had our SaaS platform pending launch. So we brand new SaaS platform. We're like, well, let's not shove it into the old stuff. Let's figure out something new. We had, again, as Brian said, reliability and uptime concerns. We run a carrier-grade network in the back end of all of our apps. That's what really differentiates us from our competitors is we own the network. We don't go through aggregators. And that network was overwhelmed badly. It was very monolithic. There's no automation in place. So to fix something, required hours of work. Releases took a day. They weren't minutes. They were days. Things of this. And then we had a competitor cloud environment that was hand-built that they were trying to run stuff in, and we're really struggling both on a capacity perspective and an infrastructure methodology. So going into this, we had a very strong philosophy on how we wanted to have the migration take place. The big thing is we wanted to emphasis on monitoring and alerting. We wanted the infrastructure to tell us what was going on versus our customers telling us what was going on. We didn't want to settle for easy. I mean, nothing we did was easy. And we wanted to build it for scale on day one. We didn't want to have to build it, get it running, and then realize, 6 months that we're too small and we have to rebuild it again. Everything was built for scale from the start. The other thing we did is we involved a lot of our customers, especially our gateway customers, the customers that are sending high throughput through us, a lot of our API and larger SaaS customers in the process with us and partnered with us in testing and had them feel involved and work with it. And then internal teams are involved. Support teams are always the ones that are getting hammered by the issues. Anytime we had downtime, it was them, and then it was to us. And so we involved them to make sure that their concerns were taken there. And as I said, the joke we have is everything before we started this migration was always lovingly handcrafted. Nothing was the same. No database was the same. No server was built the same. No OS version was the same. And so we had to really work through that. So talking through some of the technicals of our migration. So our phase 0. Coming into Zipwhip, I was a huge automation person. I mean, in previous companies, everything was automated. And going forward, we decided we weren't going to do anything by hand. Everything was going to be automated. And we made this lofty goal of even taking it to the data center. So the tooling that we have in our legacy data centers, and when we brought online some of our edge POPs, they needed to be automated and leveraging the same tooling we were building our cloud with. We wanted to make security, by default in our design, to make sure that things were secure, limited access, least privilege access principles, really following, the AWS model on access control and usage. We wanted to build on best-of-breed technologies, and we actually wanted to minimize the amount of technologies we were using. We wanted to pick ones that were more versatile and really were strong players in all the spaces. This one was interesting because, we work for a startup, and we had to go ask for money to buy F5s and Nginx and, spend money on AWS. And, it was a big ask and a big payoff. We wanted to redesign all of our networking infrastructure so that the cloud and the data center worked the same way. So we wanted to move to this more SD-WAN or SD-LAN type networking model on our data centers. Again, the automation approach was there. The access control principles were there, and so on. We moved to an immutable infrastructure. So we're not going to fix it. We're going to rebuild it. Right? We're not going to waste our time troubleshooting some weird kernel issue. We're going to rebuild it, redeploy that server. If that issue's still there, we'll investigate further. If it clears, we had other things to deal with during the migration to move on. And then finally, we're going to take a very flat /16 and move it into your traditional 3-tier networking architecture from a security perspective, and run our microservices in that 3-tier architecture. Going into this, we were really lucky. Everything we ran was already in Docker. So everything we did and in our migration was already there. So we had microservices and a lot of our newer stuff. So just kind of in a high-level diagram of where we were. So we had our central data center, which housed everything. Really, everything was there. We had a West Coast data center that kind of had some things, but a lot of it backhauled back to the central data center. We weren't really highly available. An issue in one part affected weird portions in other parts of our network. We had multiple CDNs and DNS. We were running self-hosted PBXs in the network. Firewalls were all over the place, old switches, new switches, different switches. And so we really wanted to clean that up. So to begin with, we started with our SaaS platform. So this is pretty straightforward migration, but it was our first one, and it had to be done fast. The SaaS platform was nearing release. It wasn't running well in our demo and our dev networks that were previously built, and so we needed to change that. So we moved this to AWS and made it very highly available. So your traditional 3 AZs, everything spread across the board. We also made a huge decision to go to Kubernetes. So everything we run now is on Kubernetes. We don't run any other orchestrators, and we run Kubernetes there. Due to the high transactional rate of a lot of our systems, we needed really powerful databases. And so Aurora really unlocked the ability for us to run these high throughput workloads, these messaging workloads. And so we leveraged Aurora, moved into Aurora, had to learn Aurora, had to deal with broken Aurora, and go through those. We also then moved, with all of this new fancy stuff. By the way, it's fully automated, can be spun up in an hour type of infrastructure. We did then automate all our deployments, right? And so in the same phase, we can now, really well release software, track those releases, and understand what's going on, what's actually running in our environments versus having to log into the orchestrator every single time and say, what's actually running on my environment? We knew, because the only way to run it was to run it through our deployment mechanisms that we had built out. Okay. Here's kind of the overall architecture. So we leverage, a lot of AWS NLBs and ELBs. We run Kubernetes through all of the middle tier and some of our back-end tier. We have our Aurora databases that sit in those private subnets. They're highly protected, limited access, so that things can't really get to them. We also did kind of a modified transit architecture for all of our VPCs. So we run a tooling VPC that runs some of our tools, some of our security scanning software, peers through to these offshoot networks and runs stuff in them for us so that we're minimizing access to these networks. We did backhaul to some of our corporate data center because right now we built this and our legacy messaging infrastructure was still in the data center. We hadn't moved that out, and so we were able to bring this on. Also, one of the nice things we were able to do here is introduce some very quick edge security that we had never really had before. So during this process, we moved to CloudFront as our CDN. And of course, with CloudFront, you then can enable WAF. Shield, which came out, last year, we enabled Shield on everything. And really start protecting our applications. So before, our applications, were a little bit more exposed, hanging out there. They only sat behind Nginx. There was no real, threat protection there. We were able to pull everything in there and really protect our application. You have to go through multiple layers of access before you actually hit the container running that application. And in this, partnering with F5, it's nice to talk about Nginx. We've been huge Nginx users from the beginning, and we were excited when we heard that F5 was purchasing Nginx because it really simplified our lives and also, allowed us to see Nginx grow faster and some of the needs we had with Nginx grow faster. So we leverage Nginx. Some of the reasons why we did choose this versus some of the other technologies that are out there, application load balancer or from AWS and some of those things, is really the big thing, again, we said was monitoring and visibility. Nginx provided that visibility. We had that extreme tight integration in the ingress controller with Kubernetes, so we're able to systematically control those access policies both in configuration and also in service deployment. So if anybody used Kubernetes, right? So we use ingresses a lot and ingress annotations against Kubernetes. So our Nginx servers build their own configs on updates. We had integration with DNS discovery. We had health checks. It had both TCP and UDP stream support. One interesting thing with SMS is it is a persistent connection when you make these types of connections. So we needed to be able to have these streaming type technologies available to us that At the time when we started building, the network load balancer really wasn't there from AWS, and now we're able to take the NLB and put it in front of Nginx and have these really long-lived persistent connections. Another big thing for us was header enrichment and manipulation. So we were able to open up the ability to really tweak around packets for developers without developers having to go back and rewrite things. And so it's provided a really nice tool in order to enrich those things. We do a lot of outbound proxies, which I'll show later, to manipulate those. And then again, it's fast, simple to debug, and very well known. So that's our SaaS migration. This migration, as we saw, took only about 2 months to do. It's a weird migration because it wasn't really released, but we built it all out. We learned Kubernetes, we built Kubernetes. To note, this is all before EKS came out, so we learned and built our own Kubernetes to run all this stuff and ran it on that. Our second phase was our core messaging network, and this was our largest migration. This is the meat of our business, right? The SaaS application is fantastic. Users can get the messages, but messaging's pointless if you can't send the message, and that's what this infrastructure is. So our core messaging network is a carrier-grade network. We have direct connections with every major US carrier in the US and a few Canadian carriers. We have 2 US data centers for connectivity in the US, an east and a west. We have the same in Canada. Kubernetes runs all of this infrastructure, orchestrates it for us, checks it, health checks it, and keeps it running. We run a highly available ActiveMQ broker mesh. We run 6 ActiveMQ brokers running on M5D Nitro instances, running with NVMEs, running with 300,000 plus I/O through the system. Our whole configuration is now active-active. So where previously we had a single data center that we said was active-active, but really it was one data center, we now actually truly have multiple data centers, multiple activity. We can lose many legs of our infrastructure and keep it online. And then we have on-demand scaling. So again, we're very transactional. We are currently based on MySQL, and so Aurora was really crucial for us to scale. As they release instance families, we're able to consume those to better improve the throughput and networking of our own application. So what does this look like more realistically? So this network is kind of broken up into a few different perspectives. We have an edge network that we run. So as I said, 4 data centers, 2 US and 2 Canada. This is where our carriers connect to us, and we backhaul through these into AWS. Each of these are all fully redundant, fully active, separate from each other. If the west goes down, the east stays online. All that stuff is set up there and fully health checked. So we can look at one of these legs and see how we actually traverse traffic back into the network and back out. And this is where our main egress is. So as opposed to our SaaS application where you have web servers in the front end and traffic going in and out of that, this is a different beast because now we're backhauling through private connectivity. We have VPN connections. We broadcast 4 BGP routes out of all of our data centers. We own a ton of IP space in order to manage this. Part of the reason being is carriers are slow to update. So if we own it, we can move it without them having to change anything. So we look into these migration ends. So these are our pops into our network. So we have a data center here. We run high available firewalls. We backhaul through active connections into AWS. Each of these routes back through AWS are fully separate from each other. So when we configure the Palo Altos, when we configure the F5s, each F5 and each Palo Alto are ran through Terraform and configured exactly the same way. We then BGP load balance between the 2 sets of firewalls that then balance through back through the load balancers into our application. We then leverage the Kubernetes ingress controller that F5s published in order to have configurational data in our F5s to build that backhaul back into Kubernetes and see that traffic and see what's going on there. Now, you're probably wondering, why put F5s here, right? They're expensive. Amazon has load balancers. Why not use those? Why not use Nginx, right? We've already used a ton of Nginx. And really, it was a big conversation that we had. But one of the reasons we went with F5 big IPs is because, they are the de facto standard in load balancing, in our opinion, right? They have a ton of visibility. We are currently still able to see and troubleshoot network connectivity issues very quickly due to the visibility that appliance provides that we don't obtain through Nginx, or is more complicated to obtain through Nginx, or is missing from any other type of load balancer. For us, they just worked. So to be honest, I had never touched a big IP until June of last year, right? We run 8 of them now, and we fully automated them, and we did it in 3 months. And so for us, it was just awesome. They just worked. That we were able to bring them online. F5 provided, support for us, but we were able to bring them online very quickly and scale our infrastructure very well. In our architecture, they also provide that central place to debug traffic. They sit in the middle of all of our connectivity, both in and out of this core network inside of AWS. So we can packet capture both sides of the network, see where traffic's going, and understand what's happening there. Be able to troubleshoot customer issues, our own internal issues, very easily. And as I said before, we run Terraform against all of our F5s. And so it integrates in with what we're using. We use Terraform for everything. Last year, I think I wrote 20 or 30,000 lines of Terraform to automate everything. And these just fit in with it very well and very easily. Now, into the core infrastructure of our network. So this is a diagram of that. So we run a lot of stuff here. We run a lot of servers and a lot of containers. It has a lot of load. You see here we run a couple interesting pieces that aren't present in a lot of infrastructures. We run a full spam service inside of our infrastructure. We have a vendor we work with that runs very large, high compute instances that we're able to build this. We're able to run this in Amazon cheaper than we could on-prem. We would have had to buy 3 Dell servers in order to power that and get it running, and including the power requirements, the SAN requirements. These things generate extreme amounts of data on all of our messages. And we're able to scale that fairly well and bring that online in AWS and run that. Our enum tool, so the lookup tool that says your phone number is with which carrier, we're able to offload that and not even have to deal with it, right? Our enum provider built it in their own VPC, leveraging VPC peering. We're able to securely connect to them and not have to worry about that infrastructure, which is really nice for us to not have to worry, because those databases, again, get hit for every single message. So they're high throughput, and we're able to bring those online very well. As I said, we run a very large ActiveMQ broker mesh for all of our messaging. And we were struggling in the data centers and struggling with our initial move to AWS with throughput. EBS is not very fast, even though 10,000 I/O, 20, 30,000 I/O wasn't enough for us. We needed more. And so we were able to, with the release of Nitro and of M5 instances, and specifically the M5D instances, we're able to bring on these ActiveMQ broker meshes that are high capacity, fast. With auto-scaling groups, if one fails, they rebuild themselves immediately. The application reconnects and we're off and going. We don't have to touch it. And so we're able to really, integrate well with this technology. This move we did over 4 months. This was our hardest move. This is where we're falling over on one hand and we're trying to build brand new greenfield on the other hand. And so this was a lot of work and a lot of time, and we spent the most time on our migration on this core infrastructure. And this is the one that build for scale from the beginning we had to really take to heart. Our messaging throughput hasn't shrunk. It hasn't gone down. It's gone higher, and more and more and more. And so this has had to scale and scale very quickly. And with AWS, we have been able to scale and bring those capacities online almost instantaneously, right? There's no concern of, do I have to procure hardware? Do I have enough space on my SAN? Do I have enough memory or CPU? And be able to play with that. And then again, Aurora. Aurora has been pivotal for us. Its throughput, its I/O model, the ability to honestly offload the operational aspects of a database, a high throughput database, to a team as opposed to the 3 people on our team. We can call Amazon and say, hey, this is broken, help us. There's a memory leak, there's this, there's that. And we can go through and get them fixed very quickly. So that's our core infrastructure. Our final migration was our integrations platform. And this is a very interesting platform for us because it has no interface for the user. This is all back-end services that are asynchronously processed. So as Brian stated earlier, we integrate with a bunch of different tools, CRMs, and SaaS applications, things like that, to make it more an enriched ecosystem. But in order to do this, we had to modernize it. So our old integration platform was very unstable. We run Kafka. That Kafka infrastructure was very unstable. It wasn't highly available, right? I mean, if anybody who knows who like MindBody is, they send fitness reminders for classes, right? If you don't send the class reminder out before the class, it's not a very useful reminder. And so we had to build systems and things that were highly reliable, very fast, and could recover quickly in order to support our customers and provide those enrichments. Again, we went through and treated it like we did our SaaS, 3 AZs, multiple tiers. The biggest thing we did is we treated this infrastructure as a first-class citizen across the organization. It kind of was a set-aside, ran by a small team, I think of 1 or 2 people. It was really kind of forgotten about, but it was really, it was getting used heavier and heavier. And so we brought it in. We made massive improvements with Kafka and reliability, so we run huge Kafka brokers that are able to support every message being sent through them and being processed through them and consumed properly. And then it's highly available, so building it on so that if we lose a broker node or we lose an AZ, we can bring these things online and still stay online and process your class reminders. So this infrastructure was just, like this. We have our SaaS application that has a messaging producer. So every text message you have, if you have an integration enabled, we shoot it off into this high throughput Kafka stream. That Kafka stream is then consumed by a set of microservices that all run again in Kubernetes, and then do things, right? We have outbound, we do have some few inbound. And then once again, we were able to do some interesting things with Nginx here is, as opposed to our integration developers having to do mutual TLS auth, header enrichment, API key enrichment in their applications, we were able to bring on new endpoints in Nginx, enrich those payloads, as opposed to calling the endpoint, the public endpoint, they would call our internal endpoint, which would proxy it on. So they didn't have to make a ton of changes in their application. They could just use our stuff, which was already built to do that. And of course, those who write Java know that Java and SSL isn't super horribly fast, and Nginx is way faster. And so we're able to do that. And so again, we're able to leverage and clean up and then provide visibility, running it through these proxies, these outbound proxies. We're able to see where our traffic goes, how it's going there, is it failing, things of that sort. So again, just to kind of recap our migration, we did it with a small team. So I didn't really touch on this, but there's 3 of us that did all of this work. There's only 3 of us up until this point. When we were done, then we hired more people for some reason after the fact. But there was 3 of us. The 3 of us, we were supporting our NOC, supporting support, supporting the legacy application, and trying to build the new application and the new infrastructure. Learn Kubernetes on top of it all, which is not very straightforward, especially at the beginning of last year, and bring it online. We currently have 5 data centers, one of those being our legacy data center across both the US and Canada. Our data centers are streamlined such that we just order gear, it shows up, we bring it online, apply a Terraform template against it, and it's done. So we've streamlined those. As far as networking gear, we run 8 Palo Altos, 8 big IPs. We have some 50 some odd VMware VMs running some legacy infrastructure. We run over 24 AWS accounts with upwards of 500 or 600 EC2 instances, 80 RDS instances. We have 15 Kubernetes clusters running of our own, upwards of 1,500 plus Docker containers, and these numbers are from the summer, and they've gone up. And right now, the team that runs this from the operational side is only 6 people. And so we're able to bring this online. We're bringing the devs into the process as they have improved performance on their applications to help run this, and have really been able to build a system that supports this. Some of our big wins, we were at 4 nines. So we went from, I think we were lucky to be 2 nines at times, to 4 nines. We standardized our release process, and we're still standardizing it, but with this new infrastructure, the idea of being able to automate the releases, we've done way more releases in the last year than we've done in the last 2 years, and releases go way quicker. We can release stuff during the day, which was unheard of. When we brought that up, people would lose their mind that you can release during the day. We have modernized the application and the infrastructure. We've increased the quality, the speed. Due to this native monitoring, which I really didn't touch on, we run Prometheus across the board for all of our stuff. Each infrastructure has its own Prometheus cluster. We monitor our infrastructure with Prometheus. We monitor AWS with Prometheus. Our developers integrate with Prometheus. Everything's in Prometheus. And so we collect, upwards of 5 to 6 million metrics per environment per day inside of Prometheus in varying amounts. And so we have a lot of application performance and a lot of application insights due to this infrastructure.
All right, thanks, Colby. We're going to round out the migration story by just talking about some additional operational changes that happened as a result of moving to AWS. I think it's super important to talk about the technical things that happened, but some more of the subtle things, in addition to just hiring more people, because we still had a business that operated, there were some other things that happened. As Colby had mentioned in his lovingly handcrafted comment, right? We've moved from that world to one where we practice infrastructure as code with everything. There are no exceptions. It's not because it's a network appliance, you manually configure it. No, that's not how we do things. So, everything is done through infrastructure as code for the purpose of being fast, reliable, and also repeatable. As Colby mentioned, we run a lot of gear still. We have a lot of services that we operate. So infrastructure as code is vitally important to us. Platform reliability and stability, our numbers have increased, but that it's not just a number to us, right? We put ourselves in our customer's shoes and understand that businesses rely on text messaging as part of their normal operations. Their livelihood uses our platform. So platform reliability and stability is a focus not only on our team, but across the rest of the development and engineering organization, as we've moved more towards a DevOps culture, which we'll touch on in a second. We got the opportunity to really start greenfield, right, in AWS. And so part of that opportunity was to leverage the mantra of security first approach. And for us, with text messaging, you can imagine some of the things that are in text messages. Those are incredibly sensitive to our customers, and privacy and security of those messages is at the top of our priority list, right? And so we leverage a lot of different services within AWS to do things like encryption in transit and at rest in those Aurora databases. And all this is typically just a click of a button or a check of a checkbox to enable encryption. So it makes it very easy for us to adopt this security-first approach, whereas before in the traditional data center, we'd have to procure HSM appliances and various other tools and hardware to be able to accomplish security. And then moving towards DevOps. So I know that this is a somewhat overused phrase, or word, but DevOps to us is really building that culture within our engineering organization. So we've moved from the shift of, hey, just get it working and keep it online, to really making sure that we're empowering our developers as an operations organization to work with us and partner with us by building out engineering systems and guardrails and moving to more of an on-call engineering culture where our developers are really partners with us in this journey to make sure that we focus on security, build in platform reliability and stability and uptime, and adopt things like infrastructure as code. And then lastly, in addition to the hiring of more folks on our team, what we really look for in an engineer is somewhat different than I think other places do. We really look for diverse background and experience within our engineers. Someone that may have many years in the same role as one type of engineer isn't typically the person that we're looking for in our later stage startup. We're looking for folks that have really taken on the challenge of diversity in their experience and in building new skills, whether it be in AWS or Kubernetes or some of the technology that we run. And also, I think it's vitally important that we provide visible career paths for our folks on the team. Growing from 3 to 6 that's not huge growth, right? We're looking to move beyond 6 to 15, 20, 25 engineers. And it's one thing to tell an engineer that comes in to just make sure to keep the infrastructure online. We have to be very, very clear in terms of what is the career path at Zipwhip and how does that translate into the work that you perform? And so we've taken a big focus on that aspect of things. The 24/7 network support has been something that's worked very well for us as a result of this transition. We have a 24/7 NOC today that interfaces with some of our large reseller network operations centers as well. It's amazing to think about the comfort that our customers get when they call in and they get a human being on the other side of the phone that picks up at 1 o'clock, 2 o'clock, 3 o'clock in the middle of the night or early in the morning. And it doesn't necessarily, that person doesn't have to fix the problem, but just acknowledging that and making sure that those requests are answered and fulfilled in a timely manner has been amazing for us, as well as our network operations team. And then we're always continuing to invest in security. So we've shifted the model of a centralized security team to being a shared responsibility across our engineering team. Okay, so we don't have a huge investment in security engineers, security analysts, and a dedicated security team. We're still small enough of a startup where this responsibility is shared amongst our engineers. And what this looks like is ongoing remediation, adopting tools that give us that instant feedback and those feedback loops into our engineering team so that we can address remediation quickly and not have to have a lag in time. And we've also started building more security tooling into our CI/CD pipeline. So this enables our developers to kind of share that responsibility of making sure that their code is secure before it makes its way into any production environment. And this has been a big change for us and something that has really, I think, has really enriched our developers and given them a sense of ownership and accountability that was previously put on Colby's team entirely. So these are some of the changes that we've seen outside of just the technology and things that we've built into AWS. And I think it's really important to bring these things up and explain that it isn't just all about the technology. There's obviously people behind these migrations as well. Okay, and with that, we're going to open it up to a Q&A for the last few minutes here.